Hi, students. This is Mr. Halpern here, and Margaret. Say hi, Margaret. And I wanted to do this. This will be a series of 4 videos on agriculture and some of the history, and then some of the possible solutions that we have for making it more sustainable. And this picture here is, a classic garden, but it's classic in the way that it's sort of more traditional. We don't actually garden this way industrially for large amounts of people. We typically farm in monocultures, which means that what you see here would be the same thing over and over again in very, very compact rows here. And so these are the lecture objectives. I won't go through them too much, but these are really the main questions that you want to be able to answer by the end of the 4 videos here for agriculture. And it continues to this page as well. Okay, so it starts off with a case study about organic farming and genetically modified organisms. So, 2 people, Michael Baxter and Steve Marsh, were neighbors. Their land was adjoined in one particular spot, and Steve Marsh was growing organic, and Michael Baxter was growing Roundup Ready canola from Monsanto, a company that makes genetically modified organisms for growth and food, but also Roundup, which is a type of insecticide. And so this is a picture of their land, and as you can see there, there's a line, the purple line, that's sort of, those 2 plots of land adjacent. What happened was Baxter was harvesting his canola, and some of the seeds and stock blew into Marsh's organic fields. And then the organic inspectors came in and decertified the organic crops on Marsh's lands because there was the genetically modified organism starting to grow in his fields because it blew into them just sort of naturally. And so Marsh sued Baxter for his loss. He lost a lot because he was decertified as an organic farmer, and there's a lot more expense that goes along with being organic. And so he couldn't sustain that. So he sued Baxter for that. And it went all the way to the Supreme Court in Australia. And Marsh ultimately ended up losing that case, and that it declared that Baxter was not doing anything illegal. And so Baxter was allowed to grow the genetically modified crops, but there's essentially a zero tolerance policy threshold for genetically modified organisms in organic crops. So there's a high level of I guess quality for the genetic or organic crops. But what that does is it makes it extremely challenging for people like Marsh who really want to do organic farming because any compromise to their quality from genetically modified organisms is going to affect their ability to be certified as organic. So this is a little bit of the history of the shift in growth um, of food. As you can see here, the population is steadily increasing. I'm sorry, and as you see here, you see a huge jump in vegetables, fruits, grains, all of them. Um, Today, more than 1 out of every 3 acres of land is used for producing either food or fiber. That is staggering. It's amazing. We don't actually consider that here because we don't see a lot of farms in this sort of suburban area of Greenwich and Stamford and Westchester area. But if you go into the Midwest and the West Coast in California, California actually grows the most amount of food for the United States. You'll see a lot of farmland there. Why do we care about agriculture? Well, there are several reasons. Obviously, we need to eat food and we want to provide healthy food for the most amount of people. And around the world, we have an issue that we're trying to face Particularly in the 1950s and 60s, we had the boom. But the issue is undernourishment. Something like 800 million people worldwide suffer from undernutrition, which means that they're not getting enough calories every day. And most of the people in that sort of undernutrition stage are in developing countries. So if you're thinking back to our population unit, you're thinking about countries that are still in the uh, transition stage or industrialized stage, and another 49 million people are also classified as food insecure. We have food insecure people here in Fairfield County. This is a classification of people who don't necessarily know where their next meal is going to come from a day-to-day basis. Other issues surrounding food are overnutrition. So having too many calories in a day. And so we have a lot of processed foods and junk foods. And we're also living more of a sedentary life. We're sitting down at desks or on couches and playing video games or not getting outside as much. And as a result, we're having excess weight, which leads to heart disease, diabetes, stroke, cancers, um, and the list goes on. The third issue that we try to deal with is malnutrition, which is the shortage of a particular nutrient. For example, people who are protein deficient have a condition known as kwashiorkor, which is a bloating of the abdomen as a result of the lack of protein. And this is resulting in hair loss and mental disability. And marasmus is another type where it's loss of calories and protein deficiency. And iron deficiency is a form of malnutrition. Not having enough iron is known as anemia. You're anemic if you have um, low iron. Again, going back to the history of agriculture, we have to go back to where agriculture started. About 10,000 years ago was the Pleistocene epoch, and we were hunter-gatherers before that. And around 10,000 years ago, we started to see the climate warming, and as a result, we were allowed to or able to stay in one place rather than move with the seasons. And that allowed us to have more permanent settlements. And as you can see here on this map, there are a lot of foods that were grown all over the world. Some of your favorite foods you might not have known were originally from, say, yams from South Africa, right, or coffee from Ethiopia. Now we have coffee grown all over the world. And it started off as traditional agriculture, where we have the cultivating and harvesting and distributing of crops, and we use human and animal power to do so. Um, and this is really just subsistence farming, which we call subsistence, meaning you're subsisting on the food that you produce, and you're producing just enough for your family. And conversely, we've now shifted to industrial farming, so it's an economy, a business, and this is large scale mechanization. So we're using more fossil fuels as a result. We have to increase the amount of water, so increased irrigation. We also need to have higher amounts of nutrients in our soil, so we use synthetic fertilizers to get there faster. And we have to protect our crops for higher yields, so we use chemical pesticides. So all of this is very different than traditional agriculture. Some aspects of traditional agriculture that you see if you drive out to the Midwest or you fly over the Midwest, you see a lot of monoculture, which is where you have vast areas growing one particular crop in very organized rows. Conversely, with traditional farming, you have polyculture, where you're either every other row you have something different, or you're rotating or mixing your crops with seasons. What that does is it helps to keep the balance of nutrients in the soil, and also helps to increase certain nutrients in certain parts of the year. So you would grow a bean, for example, bean plants or legumes right next to a non-legume, because legumes increase the amount of nitrogen, if you remember from the nitrogen cycle. We have nitrogen fixing bacteria there. So again, we're contrasting these two, traditional and industrial, and we're going to be, talking about that a lot. At the beginning of the 1950s, as a result of this increase in population, we had to come up with a way of feeding all these extra people. And so we had the Green Revolution, which introduced new technology, new crop variations that were much more high yielding, larger, and farming practices throughout the world. So it was good in that it increased yields, but it reduced the starvation, but it also degraded soils, water supplies, and decreased pollinators. Particularly in the 1940s with Norman Borlaug, where he increased the strain of high yield strain wheat. That was particularly important. He developed something that was disease resistant. And they were tripling their wheat production as a result. And this was then applied to India and Pakistan, and it saved a lot of people's lives. Along with that, though, they were importing synthetic fertilizers and pesticides and using much more intense irrigation methods and fossil fuel powered machinery in order to increase this yield. And so, as a result, you have India transforming its country from high starvation rates to a net exporter of grains, which is amazing. It also helped to increase the per person food production, right? So we're also eating a lot more as a result, too. So, as we said, we have monocultures where we're growing a lot of the same kind of food. But as you imagine, what originally was there was a biodiverse area, and we had to clear that, and now we're growing the same crop. So imagine the diversity in that area, not just of that particular crop, but what grows in the soil, what grows or eats that particular crop. Obviously, the biodiversity just goes way down. We mentioned irrigation. Irrigation is super important. It is the way in which we are getting water to our crops. And we have particular crops like rice that use a lot of water, for example. So, for example, you have flood and furrow irrigation of cotton, for example, that has a lot of water need. Up to 70% of all fresh water withdrawn from natural sources is due to irrigation. That's phenomenal. That's amazing, a high amount just for food. Here are the problems, though, when we have a lot of irrigation. We can get waterlogging, which means that if plants sit in water too long, they can actually drown the plant roots and deprive them of gases from the atmosphere. You can literally suffocate those plants. Another problem in irrigation is salinization, which is exactly what it sounds like. It's a buildup of salts in the soil layers. And basically, what happens in drier layers, what we have is evaporation over time of water. And what's left is a mineral rich water. And over time, that just constantly gets richer and richer and richer. And so you have to change that water out. You have to flush the soil. You um, let it sort of regrow itself. One efficient way of reducing water use is to match the type of irrigation with the crops and the climates. Um, and so government subsidies in some arid areas have made water artificially inexpensive, and that's a problem. That makes it easier for you know places that don't normally have a lot of water to be able to get it financially, and that makes an even already a dry area even drier. So this is conventional irrigation. As you can see, there's a lot of evaporation with this sort of spray method. A better method is actually switching to drip irrigation because you don't have that spray, you don't have as much evaporation of the water. Also, how do we feed our plants, right, with nutrients? Obviously, we have in our soil, we have natural nutrients all the time. However, when we're constantly growing and constantly pulling up those plants that are growing from it, we're depleting the soil. So we have to constantly put in nutrients. So we have organic and inorganic fertilizers. Inorganic fertilizers are synthesized, they're manufactured and mined from the ground, yet organic fertilizers are made from natural sources like animal waste, manure, crop residues, so parts of crops that we don't eat, like the husk of a corn, for example, charcoal even, um, and compost. So over time, we've noticed that fertilizer has gone up, in particular, the amount of inorganic fertilizers that we're using since the Green Revolution. Unfortunately, these also leach a lot faster into water, and that causes eutrophication. You should remember what eutrophication means. I'm not going to go into detail about what eutrophication is, but basically, again, runoff of these inorganic fertilizers causes an increase in nutrients in the water and eutrophication, hypoxia. So what should we do? Drip irrigation, we said, is one example of what we can do. Also, precision agriculture. It's a practice of monitoring soil nutrient levels and only applying fertilizer when it's absolutely needed. So it's having a very high-tech monitoring system. So that's a great example of how technology can actually help us become more sustainable. Sustainable agriculture obviously also embraces organic fertilizer, and we're trying our best to have water retaining crops. And as we said, again, improving technologies, organic farming, greater use of genetically modified crops might actually be better because these crops might be more water resistant or insect resistant. That actually might help. And that's it.